Hello everybody. Welcome to today's AMA. I'm Clayton. Thank you for joining, Alice. How are you today?
Okay, the usual.
Yeah. Okay, so I'm just gonna move on to ask you a couple questions, and then we're gonna move on to answering the questions from our community. So the first question that I'm going to ask you, Alice, is, in regards to transaction fees calculation, can you explain how to calculate how much fee was spent for the transactions based on this account and the two transactions?
What are the two transactions?
So one transaction is, when during the staking is the create deposit. And then the second one is the stake deposit. So, some of the problems that we encountered was, the gas consumption for the two operations are different. So, maybe we could talk a little bit about that.
Well, the gas cost denominated in grays for any transaction is the product or the multiplication of the amount of gas units expended in the execution and how much you're paying for each gas unit. Users have control over the second parameter. You can set a base fee and a priority fee per gas, and there are reasons why you would want to set this higher, reasons you want to set this lower, but a lot of the variability in the cost of a transaction is how many gas units are expended in the execution of the transaction, and this is not user determined. This depends on what operation you're doing. Some operations do very simple work. You mentioned create deposit, that doesn't really do much. That just updates a little bit of state. You also mentioned stake deposit, which does a fair bit more things. In particular, when you stake a deposit, the runtime or the VM, I guess, of the blockchain needs to ensure that your stake, or needs to compare your stake with existing stakes. To try and figure out if your stake is big enough to be included in the pool. And furthermore, whether the pool is big enough to be part of the validator set if it's not already. And that's extra work compared to what the runtime does with create deposit. So you'll pay more. Instead, that will take more gas units to execute.
Lovely. Very clear to me. Thank you, Alice. So the second question, when are gas fees charged?
They're charged when your transactions become included in the block. That's all. Whether or not your transaction fails or succeeds, well, hopefully your implementation, the client implementation you're using is programmed well enough that it always succeeds. But transactions. You pay gas for every transaction, and they get included when your transaction is included in the block. It means when one is pending, and let's say if the transaction is dropped or lost, it doesn't get to be included in the block, then it's not charged.
All right, cool. So how are transaction fees determined, and what factors affect the fee amount?
What are transaction fees determined? I think this is kind of an extension of my first question, or rather my first answer. I guess you're asking me this again, so I'll give more detailed question, or more detailed answer, really. Again, there's like two factors to how much you pay for gas. There's the user input, which is gas, how much you pay for, how many grays you pay for a single gas unit you use, and actually first, the other part is how many gas units are actually used. It's more interesting to me the second aspect, because it's very subjective. I mean, like I I said in my answer initially that the gas unit is proportional to how much work an execution does. But how do we define work? It depends, right?
Yeah.
Computers do all kinds of work. There's storage, there's computation, there's energy use, there's like memory, there's how many execution units you use in CPU. We kind of quantify this. It's very hard for me to talk about this in this single AMA, but I think the protocol specification, actually the gas section or the gas chapter, the protocol specification, does a commendable job. Does a commendable job explaining how we chart how the ratios or how much we deem how expensive how much work like a unit of storage is, how much work a unit of computation is. I think the general rule you have to know that I can say in this call or in this live. Storage is much more expensive in a blockchain than computation.
Lovely. So, for anyone who wants to dive a little bit deeper into the subject, you can refer to this specification.
Which is on GitHub.
Yeah.
What factors affect the fee amount? Yes. So, it's basically storage.
Yeah.
Make sure your transaction doesn't use that much storage.
Cool. So, how does ParallelChain Mainnet handle congestion and high transaction volumes? Would this impact or have an impact on the fees?
It doesn't affect on the amount of the base fee that you have to pay. We do the same thing as Ethereum does with their 1,559 EIP.
Yeah.
Which is we adjust base fee according to demand. If blocks are more full than target, the base fee will increase.
Yeah.
If blocks are under full, then it will decrease. And we try to get good equilibrium this way, where blocks are half full, same as what Ethereum does. Yeah. So high congestion, high transaction volumes will have an impact on transaction fees by increasing base fees.
Lovely. Thank you. So, last question from us is, what blockchain feature does ParallelChain have to prevent users from paying excessive transaction fees?
Well, at the end of the day, all blockchains kind of do the same thing, which is do some computation and then store some state. There are optimizations that you can do on the edges that we do as well. I mentioned storage being one thing that's very expensive in a blockchain. Universally, one small way, nothing super nuanced or anything. We use less storage than other blockchains is that our transactions. We have another layer of commands. That other blockchains don't have. Other blockchains you have to do. Let's say you want to stake, and you want to call a contract, and you want to transfer something. That has to be 3 transactions because those are 3 operations.
Yeah.
We save a bit of storage in our blockchain by having this notion of a command and allowing transactions to include an arbitrary amount of commands. So you can actually do more operations
in one
transaction, and you save on a bunch of data.
Yeah, that's
because
something.
You don't have to sign. You don't have to include more signatures. You don't have to include more hashes. You don't have to include other fields in the transaction header.
Yeah, that's great. For the end user, to save some gas fees. So, anything that you want to say to anyone here, in particular, before we move into the next section
about fees? I guess I'll just say that I think the way we do it is pretty common. You won't find any surprises. And anyways, the specification talks about them pretty nicely. That's all. Yeah.
Lovely, thank you. So moving on to the community questions about transaction fees is the first one from Wake_222. He mentioned the formal verification feature sounds very exciting and useful. So far, there's little information about it. When is it going to be released on the mainnet?
Well, I see in your laptop that there's two parts to this question.
Yeah.
I think I shall answer the second part first.
Okay. So the second part of the question is, can you tell us a bit more technical details about the formal verification feature and what are the advantages?
Well, formal verification, in quotes, is really what we've been using, what we've been calling our very broad efforts in the company and in the team towards building tools that very broadly try to make it easier for contract developers to write contracts with less bugs and with less unintended or unspecified behavior. I guess it's kind of a misnomer to call it formal verification. Specifically, emphasis on the word formal. It really should just be verification. Our work on this is broad. It does not only encompass formal methods. What is formal verification? Like more specifically, besides like talking what I said just now, trying to help people write contracts with less bugs. There is well, I said we do verification, not really formal verification specifically. I guess there are two areas that we try to work on. One is true formal verification in the computer science sense, which is typically programming languages. Programming languages are not very, computers are these very funny things. Computers, how am I going with this? Computers are built as this very, very deterministic, very rule-following machines. But actually the languages that we program them with have lots of edge cases and funny mathematical behaviors that will make someone in the sciences, like in physics or mathematics, cry because it's so unpredictable, the behavior of programming of programs, and that's because of the nature of programming languages. Programming languages are designed for not quite rigorous people. So the traditional formal verification approaches have been really trying to create another language to write programs with, or to specify programs with, that is more mathematical in the broad sense. That means less side effects, less non-determinism, and then using these languages to write the contracts instead of using typical programming languages, or using it in conjunction with a typical programming language. Let's say you have a specification written in the mathematical language, and then you have a contract written in the normal programming language. There are methods you can use to compare the mathematical description of the program with the programming description of the program, and ensure that the program meets the mathematical description, and that somehow makes it more secure. And something that's not formal that we're also trying to do is trying to do machine learning, using machine learning mechanisms to detect bugs. This is not formal because it's not mathematical. I mean, I'm throwing these words very loosely, but one of the things that the mathematical formal verification tries to do is try to get rid of non-determinism, but machine learning is non-deterministic in nature.
Yeah.
Or it is deterministic, only in the very like pedantic sense of the word. But yeah, I don't think that's another thing that we're exploring, using machine learning to detect bugs. Yeah, that's essentially what we're doing with this verification. When will it be released on Mainnet? I don't think I can give it a definitive answer at the moment. This is really one thing that we're doing that falls squarely under advanced development, or even spilling into like industrial research. And when you're dealing with research problems, I think it's detrimental to the quality of the result if you have a deadline determined by business. There are deadlines determined by like researchers, but not deadlines determined by business. Not sure. Can't give the definitive answer.
Understood. It takes time. All good things takes time, and So, a question from Jogo Boyo. Why send a full node, and why only 10 validators at the moment?
I think the answers are to these two questions are kind of related. We aim to release the full node when we're proud of it. When we think the code is nice, you'll enjoy reading it. Programmers will enjoy reading it. When we've ironed out any possible bugs, we don't want to release source code to the public and have some very sneaky people
Understood.
investigate any possible like cases that we haven't handled.
Yeah.
What else did you say?
So
and another reason would be, we also want to make sure that when we release the full node software or the source code, you guys know how to use it. So we want to try and prepare the best docs we can. That takes time.
Great. So another question from Chili Chief. Regarding the gas fee, a gas fee is lower than 1 gray per gas allowed by the protocol?
No. I think that's a very straight answer. It's just, well, I understand that you guys may be worried. You guys want to make sure that your transactions are as cheap as possible.
Yeah.
Rest assured, we did some very rough estimations before settling on the denomination of gray. We think even at 8 grays per gas, transactions are damn cheap enough, actually. And if we the price increases to a level like beyond our estimations, then there are ways to get around this. Perhaps we can, instead of denominating the cost per gas of a transaction in grays, we can denominate it in milligrays or micrograys. But computers are just not very good at floating point numbers.
Yeah. So next question from Moody. How's the XPLL team or ParallelChain team planning to counter inflation in the coming years?
We have a pretty well-defined issuance schedule, which you can also find in the specification, or I think you can also find it in the economics white paper. We're issuing 8% at the beginning in this year, and that decreases linearly until the 11th year. Well, it will go down to 1.5% a year. That's the defined schedule. We don't intend on deviating, and we also got to keep in mind that 1.5% inflation may be, well, I think that's pretty low. If you guys think that's high, you got to keep in mind that base fees are burnt. So hopefully, when the network becomes busy, good, it might be deflationary even in the currency.
So, okay, another question, circling back to Chili Chief. Currently, the latency of over 10 seconds per transaction is too long. I understand that the ParallelChain native rollups will improve on that. What is the expected latency once rollups goes live?
Rollups won't solve latency. In fact, rollups will make it worse. Can't blame you, Chili Chief, I guess. There's a trade-off between throughput and latency. You can have high throughput, but you need to pay in latency, or you can have low latency and you have to pay in throughput. Rollups fall squarely in the camp of let's have high throughput, but we sacrifice latency. And different applications will prefer throughput or latency depending on the nature of the application. What are some things we can reduce latency? We can reduce the block time. We can come up with a smarter consensus algorithm that, right now, our finality, we have finality once a block has 3 successors. There are consensus algorithms known to the research community that have lower finality latencies, i.e., you need less successors, maybe like only 1 or 2 instead of 3. But I think we're generally happy with our current selection, our current position in the throughput latency sort of trade-off spectrum. And we do prefer optimizing for throughput than optimizing for latency. Personally, I think blockchains aren't going to be something that people use for like time critical operations. Just from the nature of a blockchain. It's very expensive to use. It's not something people are going to often use. Something people are going to use rather rarely, at least public blockchains, rather rarely for highly critical operations. And for highly critical operations, I think people will be more fine waiting longer.
Lovely, thank you.
It's not like you want to post on Twitter and you put it on a blockchain and you want to make sure that and the tweet comes up in 1 second. No, it's something more critical than that. I mean, or at least like something more enterprise than that.
So I think time's up. Any questions or anything that you want to say to the members here live?
I guess if I'm to be very, what's the word? Not frank, but very transparent. Not transparent either, like very cordial, something like that. So one of these word synonyms. English is not my first language. I just hope that you guys will be more patient. Be more patient. I know that this whole crypto thing is seen as an investment. I hope people will see it more as a technology that's speculative and therefore challenging to deliver on quarterly or business cadences.
Thank you. And there's a couple of topic questions brought up by the community. I guess don't have time to go through all of them, but I would select a couple to try to answer them during this a minute or so. So a community member Keyplay asked on Discord something about the engagement of our community levels, and mostly active and moderators, and then he think that we should be closer to the community to increase transparency. So maybe I could answer to that. Of course, that's not the impression that we want to give. We're trying to answer all product related questions, and if there's support needed from us within 12 to 24 hours. So it was really great, to also have our ambassadors to help answer some of the questions that made there. And of course, not all the questions can be answered by them. We do hope that we can address all the questions from the community quickly and effectively going forward. And there's another question regarding the ambassadors program. So, some numbers that I can share here is, since launch, we had around 3,000 ambassadors that signed up for the program. And they've created, over the past couple months, over 1,000 posts. 3 events and meetups were organized by them. And, just in the 6th batch alone, which goes from the end of March to mid-April, our ambassadors have generated around 60K impressions on social media channels. So safe to say that, each month they're helping us to generate around 100K impressions on social media. And so far we have around, 170 to 200 ambassadors that have submitted tasks to us and that has been approved by us. And, there's also another questions about community giveaways and wallet beta testers and how did they benefit the project. For example, how many bugs were found because of testing. So I could say, we had a developer early access and bug reporting program active that was live in testnet 3. We had received around 700 reports in total, although some of them are quite duplicated. We still think that the feedback given was good and quite useful for our development team. And about Parallel Wallet Beta, we had around 100 testers in total with a completion rate of over 80%. And many of them are long-term community members since the beginning, which provided genuine feedback to us in great detail, like feedback forms, even jumping on Zoom calls and so forth. So, it just helped us a lot to identify opportunities to improve on. So, thank you everyone for tuning in. Thank you, Alice, for being here. And looking forward to see you guys in the next AMA. Have a nice day and goodbye.